Okay, we're working on families of functions. We are trying to figure out what that function right there is called. It starts with an L.
Linear.
Thank you very much for bringing your brains to school today. Bring your homework too. More specifically, this is a constant function. Okay. Constant functions are y equals 5, y equals 2, x equals 1. Okay, there's only one variable. You guys know how to graph those. Okay, that's called a constant. If you want to write this down. Now, we're going to change it a little bit. Okay, so that's the constant. Here's a linear function. The constant, of course, is linear too. So we've changed, if you look at this here, we've changed the x term to have a number in front of it. So there's a y equals x. It's linear. You know what a linear function is, right? What's the degree of a linear function? You remember what degree means?
The number, like the square. It's like square root.
Right. It would be something like y equals x. You can't see that probably. The degree of that function is 1 because the exponent on x is 1, right? That's linear. How about a quadratic? What is that shape like? Yep.
Oh, that's not the two.
What's the degree of a quadratic?
No.
2, because it's y equals x squared. Okay. Now I can manipulate it. That's y equals x squared. Okay. This here, so families of functions deals with the, here's the parent function. What happens when I do x squared plus 1? What's the y-intercept? It's 1, right. Okay. I can also move it down. So this is x squared minus 2-ish. It's actually minus 1 point, something, but. What if I move, go to 0. What if I move it left 2? It's x plus 2 in parentheses squared. So families of functions deals with transformations, translating, up, down, left, right. And I can also goof with how wide this is. And if it flips down, what is the equation of that one? Yeah, it's a negative something. Negative x squared, maybe.
Is this the y as y or x approaching?
We're going to get to that too. Not this time, today, but. Okay, so we have a quadratic, a cubic, that's actually a negative x cubed. Notice it goes opposite. So the cubic is, what does a quartic look like? It's a letter.
W.
It's a W, right? So, or an M. This is a negative, x to the fourth. And then a quintic, again, is going to look like a cubic. It's just going to have an extra bump most of the time. Okay. And we can mess with a whole load of these things just to make it different. Okay. You can do all sorts of stuff. We can move it up and down. We can move it left or right. Okay, so you have a constant, linear, quadratic, cubic, quartic, quintic. Those are called the polynomial functions. You're going to learn to take the parent function and move them around. It makes graphing it a lot easier. Sure, we're good here. Ah, yes. Just a primer. We're going to get, I'm not going to hold you accountable for this right now, but we're going to get to trigonometric graphs. So this is sine x. You're used to working with sine, cosine, and tangent on right triangles, yeah? The basis of trigonometry is being able to graph them as sine and cosine waves. I'm going to show you how to do that and relate it to music, actually, as any of your music nerds. Okay. Exponentials you've seen before, I take it, in biology.
Yeah.
Logarithms. We haven't got to that yet. Logarithms are the inverse of exponentials. And then the others we don't need to worry about. So the others that you'll want to know, go ahead and search it up. Okay, the square root function. It just starts at 0, 0 and goes up and out. And again, we can move it up, down, left, or right. Okay. The what does absolute value look like? It's just the v. You know that v. Okay. One of the other new one is a rational function. Okay, it'll look like that. Let's see if I can find a better one. Defeating my zoom technique. And you see the line goes up to infinity here, and down to negative infinity, out to infinity here, and then to negative infinity. These vertical dashed lines are called asymptotes. Does that ring a bell? We went over them last year a little bit. Asymptotes. And then the other one you already know, which we're not going to worry about much, except that you know the name, the step function, or the greatest integer function. I'm not going to ask you to graph that again. Just know what it looks like.
What do you think they use?
That's where we're headed here. Okay, so first, can you identify them? Constant, linear, polynomial, square root, absolute value, rational, greatest integer. It's all in your book. Okay, it's in 3.2. So can you identify it? Tomorrow we're going to go over graphing them, and we're going to play a little matching game. Okay. But right now, you should be able to do what, 13 through 27. Maybe not. You can start on the review problems. That starts at 45. Okay. Again, tomorrow I'll show you how to graph them, and that'll give you a much better idea of what you're doing there. But today you got the primer. Any questions? Okay.